Hello and welcome to this lesson on audio and video capabilities in Android development. In this lesson, we'll cover the basics of utilizing audio and video files and content in your Android applications. The Audio Manager class provides access to volume and ringer made controls. This class also manages audio sources and audio output on the device. You can use context.getSystemService with the parameter context audio service to get an instance of this class. Audio Focus is a set of APIs for managing audio interaction across multiple independent apps. The Audio Manager class allows for requesting and holding the audio focus for the stream the application will be using. This should be done before the application starts playing any audio. This is done with a call to the request audio focus method, which will return the enum audio focus request granted if your request is successful. If your app can request audio focus, then it follows that it will in turn lose that focus when another app requests it. How your app responds to a loss of audio focus depends on the manner of that loss. The onAudioFocusChange callback method of the AudioFocusChange you register when requesting audio focus receives a parameter that describes the focus change event. Specifically, the possible focus loss event mirrors the focus request types that we would make when requesting focus. These can include permanent loss, and transient with ducking permitted. The sample class manages and plays audio resources for applications. A sample is a collection of samples that can be loaded into memory from the resources inside of the APK or from a file in the file system. The sample library uses the media player service to decode the audio into raw 16-bit PCM mono or stereo streams. This allows applications to ship with compressed streams without having to suffer the CPU load and latency of decompressing during playback. In addition to low latency playback, SoundPool can also manage the number of audio streams being rendered at once. When the SoundPool object is constructed, the max streams parameter sets the maximum number of streams that can be played at a time from this single SoundPool. SoundPool tracks the number of active streams. If the maximum number of streams is exceeded, SoundPool will automatically stop a previously playing stream based first on priority, then by age within that priority. Limiting the maximum number of streams helps to cap CPU loading and reducing the likelihood that audio mixing will impact visuals or UI performance. The Media Player class is a class that can be used to control the playback of audio files and streams, and video files and streams as well. This class can fetch, decode, and play both audio and video with minimal setup. It supports several different media sources, such as local resources, internal URIs, such as the ones you might obtain from a content resolver, and external URLs or file streams. From this state diagram, we can see that the media player object has the following states. When a media player object is created using new or after reset is called, it is in the idle state, and after release is called, it is in the end state. Between these two states is the life cycle of the media player object. In general, some playback control operations may fail due to various reasons, such as unsupported audio-video format, poorly interleaved audio-video, resolution set too high, streaming timeouts, and other similar situations. Thus, error reporting and recovery is an important concern under these circumstances. Sometimes, due to programming errors, invoking a playback control operation in an invalid state may also occur. Under all these error conditions, the internal player engine invokes a user-supplied onErrorListener onError method. If an error listener has been registered beforehand via the setOnErrorListener method call. Calling the setDataSource with file descriptor parameter, or setDataSource with string parameter, or setDataSource with context and URI parameters, or setDataSource with file descriptor, long, and another long parameter, transfers a media player object in the idle state to the initialized state. A media player object must first enter the prepared state before playback can be started. And it is important to note that the preparing state is a transient state, and the behavior of calling any method with side effect while a media player object is in the preparing state is undefined. To start the playback, the start method must be called. After the start method is called and returned successfully, the media player object is in the started state. The isPlaying method can be called to test whether the media player object is in the started state. Calling the start method has no effect on a media player object that is already in the started state. Playback can be paused and stopped, and the current playback position can be adjusted. Playback can be paused via the pause method. When a call to the pause method returns, the media player object enters the pause state. Note that the transition from the started state to the pause state and vice versa happens asynchronously in the player engine. It may take some time before the state is updated and calls to isPlaying method. And it can be a number of seconds in the case of streamed content. Calling the stop method stops playback and causes the media player in the started, pause, prepared, or playback completed state to enter the stop state. Once in the stop state, playback cannot be started until prepare or prepare async are called to set the media player object to the prepared state again. Calling stop has no effect on a media player object that is already in the stop state. The playback position can be adjusted with a call to seek_to, which receives the parameter of an integer. When the playback reaches the end of the stream, the playback is complete. The video view is a class that allows to display video files. The video view class can load images or videos from various sources, such as resources or content providers. It takes care of computing its measurements from the video so that it can be used in any layout manager, and provides various display options such as scaling and tinting. It is important to note that the video view does not retain its full state when going into the background. In particular, it does not restore the current play state, play position, selected tracks, or any subtitle tracks added via add subtitle source method. Applications should have a save and restore method for these operations in their own onSaveInstanceState method and onRestoreInstanceState method callbacks. Thank you for joining us in this overview of audio and video capabilities in Android. Join us in our next video where we'll take a look at implementations of some of these methods in code in Android Studio.